E, and F right here for question number 1. So what I'm going to do here is I'm going to first write out the model solution for each part. And then once we have the model solution written, we'll look back at that solution and I'll try to highlight the parts of the solution that I think are necessary in order to get full credit. So here we go. The question says, an online company is hoping to sell a new product by placing a pop-up advertisement on their website. There are 2 different designs for the advertisement, and the company would like to determine which one is more effective as measured by clicks and purchases. For the first 200 visitors to the updated website, half were randomly assigned to receive advertisement 1 and half to receive advertisement 2. The two-way table summarizes the results. So we can see over here on the left, we've got the 2 different treatments, advertisement 1 and advertisement 2. And as mentioned, half in each, 100 in each for a total of 200. And then we can see the customer behavior based on each one of those advertisements. Either they did not click, they clicked with no purchase, or they clicked and made a purchase. So here's what question A says. It says, is this an observational study or an experiment? So first we have to know the difference. For an observational study, we usually take some sort of sample, a random sample, and maybe we give them a survey and we're looking for some sort of results, or we're just observing something. With an experiment, the difference is that we are imposing treatments on the subjects. Well, in this particular context, the online company is randomly assigning the people to either advertisement 1 or advertisement 2, which we could think of as the treatment. So the definite answer here is that this is an experiment rather than an observational study. And then we need to provide a good reason for why it's an experiment. So we're going to say this is true because the customers were randomly assigned to a treatment. And then we're going to be specific about what those treatments are here in the context of the problem. A treatment of advertisement 1 for one of the groups, or advertisement 2 for the other group. Now, in terms of what would be needed for full credit here, I'm going to try and highlight this by underlining the important parts. Well, first of all, you have to read the question and answer the question. And the question asked, is this an observational study or an experiment? Here is where we have answered the question. But then we have to explain our answer. So why is it an experiment rather than an observational study? I like the idea that we have random assignment of treatments, but we've even gone a little bit further than that, and we've explained in the context of the problem, what are the treatments that are being given here. So that takes care of part A. Let's move on to part B. Part B says, provide one piece of evidence for why advertisement 1 is more effective. Okay, so we're going to come back up here and let's look at advertisement 1 and look at the numbers. Well, how are we measuring the effectiveness of the advertisements? 2 different ways, in the clicks and in the purchases made. Well, if I look here, I see that there were 22 purchases made out of 100, as opposed to advertisement 2, which only had 16 purchases out of the 100. So clearly, if we're basing it on number of purchases, it looks like advertisement 1 is the better advertisement. So we're going to say advertisement 1 had a higher proportion of customers who made a purchase. And then I'm going to make sure here that I justify with some numbers here. So the proportion of customers who made a purchase for advertisement 1, well, that's 22 out of 100. And if we were to write that as a proportion, it would be 0.22. And the proportion of customers who made a purchase is higher than the proportion for advertisement 2. So higher proportion of customers who made a purchase than advertisement 2. And then let's also give numerical justification for advertisement 2 here, which we know is, let's see, 16 out of 100. which if we write that as a proportion is 0.16. So what would be needed for full credit here? Well, obviously we have to give a reason why advertisement 1 is better. And I think specifically, I like this comparative word of higher, the proportion of that made a purchase is higher. And I actually really like here that we've justified it with some sort of numerical explanation that includes a probability there. Okay, let's take a look at the next part, which says, provide one piece of evidence for why advertisement 2 is more effective. So now we need to try and think about why advertisement 2 is more effective. Well, we want customers to make a purchase, but we also want customers to click, right? Whether or not they make a purchase. And if you look here, if I take the total number of customers that clicked for advertisement 2, 20 and 16, I get 36 out of 100. Whereas advertisement 1, 8 and 22 is only going to give me 30 out of 100. So if we're basing the effectiveness of the ad on the number of clicks, it appears advertisement 2 is a better ad. So let's put that into words. We're going to say advertisement 2 had a higher proportion of customers who clicked. And then let's provide numerical justification for this. The number who clicked, remember we said was the 20 plus the 16. So 20 plus 16 out of the 100 total. That's 36 out of 100, which is 0.36. And we're saying that is a higher proportion of customers who clicked than advertisement 1. And let's provide numerical explanation here for advertisement 1. We've got the 8 and the 22 out of 100. And that's 30 out of 100, which would be 0.30. And clearly 0.36 is higher than 0.30. So what's required for full credit here? Well, definitely, once again, I like this comparative word here that we're saying the proportion is higher. And then we've also provided some numerical justification for that one. Okay, let's move on to part C. One customer from the study will be selected at random. Are the events advertisement 1 and made purchase independent? Justify your answers based on probabilities calculated from the table above. Okay, so if these two events are independent, then knowing the outcome of one should not change the probability of the other. So let's start with the probability of making a purchase. And if we just start by looking overall for all 200 customers, let's see what the probability that they make a purchase is. Well, out of the 200 total, we can see here that 38 out of the 200 made a purchase. So overall, 38 out of 200 made a purchase, and that is 0.19. Now, here's what we want to do to determine independence. Let's see if the probability that they purchase changes based on which advertisement they were given. So we're going to do a conditional probability here of purchasing given that they saw advertisement 1. Well, if we are given that they saw advertisement 1, we are only looking at that row, which has a total of 100. And out of the 100, we know that 22 of them made a purchase. So this is 22 out of 100, which is 0.22. Notice that is not the same as the overall probability that they make a purchase. Now, to strengthen our argument here, let's see what happens when we calculate the conditional probability of a purchase given that they saw the other ad 2. Well, now we're only going to be looking at the column for advertisement 2, which we know is out of 100, and out of those 100, 16 purchased. That is 16 out of 100, which is 0.16. So very clearly here, if I know what ad they're shown, that is changing the probability that they made a purchase, which is telling us that these two events are not independent. So let's go ahead and answer the question here. First, we want to say, no, they are not. The two events are not independent. Now we need to be very clear on our justification for why we're saying the two events are not independent. So we're going to say it's because these three probabilities that we've calculated here do not equal one another. All three of them are different. In fact, if any two of them were different, we would know that these two probabilities are not independent. So I'm even going to go one step further here, and I'm going to explain sort of the meaning of independence. And I'm going to say, knowing which treatment the customer received changes the probability that they purchased. So clearly, these are not independent. Now, what would be required for full credit here? Well, we actually went ahead and calculated 3 probabilities here. Actually, if you calculated any 2 of those probabilities and showed that they were not equal to each other, that would be sufficient. We sort of went a little bit extra here. Now, once again, you want to make sure that you answer the question that's being asked, which is whether or not the 2 events are independent. Okay, let's move on to page 2 for this question here. We've got a little bit of setup for this one. So here's what it says. The online company conducted a test of the hypotheses, null hypothesis, P1 minus P2 equals 0. Alternative, P1 minus P2 does not equal 0, two-sided, where P1 is the proportion of customers similar to those in the study given advertisement 1 that would click and make a purchase, and P2 is the proportion of customers similar to those in the study given advertisement 2 that would click and make a purchase. The conditions for inference have been met. Okay, so we don't have to worry about checking any conditions here. They've already given us that the conditions are met. So part D says, one of the conditions for inference that was met was that n times p combined and n times 1 minus p combined are greater than or equal to 10 for each group, where p hat combined is the combined or pooled proportion. Explain why it is necessary to satisfy this condition. Notice that we are not asked here to check this condition. We are asked why it is important that we check this condition. So often this is called the large counts condition. And the reason we check the large counts condition is to make sure that our sampling distribution is approximately normal. So let's go ahead and start our answer here by saying, so, whoops, let's do this in blue. So we can assume the sampling distribution, and I'm going to be very specific here. The sampling distribution in this case is the sampling distribution of P1 hat minus P2 hat, which is the difference in sample proportions. And we're going to say that it is approximately normal. And I'm going to go a little bit further here. The reason why we want it to be approximately normal is because if we're going to do some inference and maybe do a significance test and calculate a p-value, we're going to use that normal distribution in order to find our p-value by first calculating a z-test statistic, which has to come from an approximately normal distribution. So I'm going to say here, and we can use a z-test statistic to calculate a p-value. Now, which parts of this do I think are crucial or critical in order to get full credit? Well, we of course need to say something about approximately normal. But here's the thing you need to be careful of. You have to be specific in your language about what we are saying is approximately normal. You can't just say it is approximately normal. You can't just say the distribution is approximately normal. Specifically, we want to say that the sampling distribution is approximately normal. So I think that those are the 2 parts that would be necessary for full credit. All right, now let's move on to part E here. It says the test resulted in a p-value of 0.2795. Interpret what this p-value measures in the context of the study. So listen, students, this right here is the holy grail of AP statistics. It is the interpretation of the p-value. And so to help us out here, instead of jumping right into the interpretation, I'm going to draw a picture of that sampling distribution, which will then help us to write the interpretation for the p-value. So here's the picture. Let's suppose we had our sampling distribution, which we just decided was approximately normal. And just to make this very clear here, I'm going to label this as the sampling distribution of P1 hat minus P2 hat. Now, when you calculate the p-value, remember, we always assume that the null hypothesis is true. And if the null hypothesis is true, then P1 minus P2 is equal to 0 would be the mean of the sampling distribution. Now, the statistic here based on the sample, well, let's do a little bit of a calculation here, all right? The P1 hat would be the sample proportion for advertisement 1 that ended up making a purchase. Well, we actually figured that out already. There were 22 people out of 100 that made a purchase using advertisement 1. That's 0.22. And we've already calculated the proportion of the customers that got advertisement 2 that made a purchase was 16 out of 100. And so now we can find P1 hat minus P2 hat. The difference in the sample proportions here would be 0.22 minus 0.16. We have a difference of proportions there of 0.06. That is going to show up in our picture here. This would be the difference in the sample proportions. And a p-value says how likely is it to get that value or farther from what's expected purely by chance. So we want to know how likely is it that we would get a difference of sample proportions of 0.06 or greater. But let's be careful here. If you look back at the alternative hypothesis, you will notice it is two-sided, which means we need the equivalent area on the other side, which would be a difference of sample proportions of negative 0.06 or lower. So the p-value is just this shaded red region here, right? These two shaded red regions represent the p-value. And what we need to do now is we need to turn that into words, okay? So here is my interpretation of the p-value. Let's start with our assumption up front, which is the null hypothesis. So I'm going to say, assuming the proportion that make purchases for each treatment group is the same. And that's really just the null hypothesis. In fact, I'm going to write the null hypothesis in parentheses here. P1 minus P2 is equal to 0. There is a, and this is where we're going to give our p-value, which is a probability. Our p-value is 0.2795 probability of getting, now let's look at our picture here. We're trying to explain these values here of getting difference of sample proportions of 0.06 or greater. That gives me the right-hand side shaded region, that's this, or negative 0.06 or lower is going to give me the other side of that normal distribution purely by chance. So there is our interpretation of the p-value. And let me try and highlight the parts that I think are important. Definitely, the p-value is a conditional probability, and the condition is the null hypothesis. So we need to say somewhere that we're assuming the null hypothesis is true. You definitely need to have the p-value in that whole interpretation and describing it as a probability or a conditional probability. And the other thing to check for is you've got your 0.06, which is the value that we got in our experiment, but you need this or greater. Similarly, negative 0.06, and you need that or lower. Okay, so let's move on to the next part. It says, based on the p-value, what conclusion should the online company make? Now, I'm hoping this one feels very comfortable to you. Essentially, what we're looking for here is a conclusion to the significance test, where we look at the p-value and we have to make some decision about the null hypothesis. And there's a pretty good formula for what this should look like. So we're going to start with because, and we're going to compare the p-value to the significance level. Okay, so because the p-value of 0.2795, which is a pretty big p-value, right, is greater than significance level. And let's just maybe go with our standard 0.05 here. Because our p-value is large, that means that this result, this difference of sample proportions of 0.06, very well could have happened purely by chance, even though it looks like advertisement 1 is better. So we're going to say that the company should fail to reject H null. Now, the next sentence here, we need to say whether or not we have convincing evidence for the alternative in the context of the problem. So we're going to say they do not have convincing evidence that of the alternative. Now, the alternative right here says that there is, in fact, a difference between the two proportions. So I'm going to say that there is a difference in the proportion of customers like these who would make purchases between the two advertisements. So let's take a look at the parts of the conclusion here that I think are most important here. You definitely have to compare your p-value to the alpha level. We call that linkage, and we need a greater than or a less than there. You have to make some decision about the null hypothesis. Either you reject the null or you fail to reject the null. And then you want to say whether you do or do not have convincing evidence for, and then what you have here is the alternative hypothesis, but you've put it in the context of the problem. So that wraps up question number 1. I hope you did okay on question number 1. That was the 25-minute question. And I think we are now ready to take a look at question number 2.